What is your job? As a software developer, as a software engineer, what is your job? This is one of my biggest heartaches when it comes to the software developer, software engineer profession as a whole. What is your job? And if you ask that, many people say, I work on this project, I work on that project, I'm a back-end MySQL developer, I'm a back-end MongoDB, a non-relational database developer, I'm a PHP developer, a JavaScript developer, a full-stack developer, a reactive developer, a reactive Vue, whatever. Guys, that's not your job. That is not our jobs. As a software engineer, we have one job. What is this job, you ask? Well, guys, that one job is to manage complexity. To manage complexity. Now, that leads us to another question. What is complexity? Well, complexity is managing dependencies. Guys, software development in one word can come back to managing dependencies. If this thing happens or that thing happens, do this. If that or that happens, do that. Guys, this is dependent on these two things, that's dependent on those two things. How do we properly manage those dependencies? How do we invert those dependencies? How do we polymorphically override those dependencies so we don't have to have an if this is the type of, else if this is the type of? Guys, your job is managing complexity. Now, here's a really interesting thought and a really interesting topic in general. It's the topic of cognitive load. Now, cognitive load is basically the load that we put on our brains, or the load that is put on something that can process information. There are three types of cognitive load. One is intrinsic. There is the intrinsic cognitive load. This is the absolute, never-changing, immutable difficulty of a problem. Intrinsic cognitive load. Never change. It doesn't matter if you have two people, one person can do the problem a lot faster than the other. The difficulty of the problem, the intrinsic cognitive load of that complexity never changes. I like to think of it like this. Like, intrinsically, that is how hard it is. You can have one computer with more processing power than the other, but the algorithmic speed is the same. It's just, this is the fastest way you can solve this problem. It will never get faster. And it doesn't matter if you're comparing two different entities in the speed in which they can solve that problem and the speed in which they can solve that complexity, it doesn't change the intrinsic cognitive load. So intrinsic is absolute. The next one is germane cognitive load. Number 2, germane cognitive load. What is germane cognitive load? Well, germane cognitive load is the schema around processing information or complexity. It is the schema that either builds up a informational net in our brain, giving the problem, the complexity, context, semantical understanding, and yes, I am saying semantics. It's the context, it's the schema, it's the relationships we associate to better understand the problem. The schema, or the germane cognitive load, is contextual load that helps us understand the problem, which, yes, does add complexity, technically. But it also reduces complexity. Now, imagine this. Imagine you have a coder that is saying for, I equals 0, I has to be less than or greater than y, and y, or an I++, loop through it, m equals z plus A, etc., etc., etc. What if people wrote code like that? What if people wrote code like that all of the time? And if you do quit, nobody likes somebody who writes code like that. Be a declarative minimalist. Declarative and minimalist. Be declarative. Semantic understanding. Give your code, your software context. Contextual understanding. Give it germane cognitive load. Provide germane cognitive load. Load the brain with the proper information to keep the brain and the person reading your code on the right track to figure out what the hell you're doing. Don't do X plus A, M equals X plus A. Do 5 plus 10 equals 15. Write it out if you have to. Don't be lazy. We spend 80% of our time reading code and 20% of our time actually writing it. Be a declarative minimalist. Declare what you're doing and then try to minimize any of the extra visual debt. That's germane cognitive load. Another good example of this is, what if I was to describe a square? Take 4 sides, right? 1, 2, 3, 4. Well, I just drew it out right there. What if I didn't draw it out? Or what if I went to a whiteboard and drew it out, and then that persisted with Expo marker on the whiteboard? That would be even easier to understand what a square is. But what if I, instead of drawing out a square like that, or drawing it out on a whiteboard, what if I said, well, 1, a square has 4 sides. A square has equal lengths for each of its sides. The area of a square is the side times one other side, and the parameter of a square is a single side times 4. Okay. Well, that was a lot of very unhelpful information. Or specifically, it's not unhelpful, but it could have been described, explained, and provided. That information could have been provided in a much better way so you guys are able to digest that information. So, for example, I go to a board, I draw the square, here is a square. And then I say, the area of a square is this. I shade it in. To get the area of the square, I point to one side, you multiply this by this, and then I put area between the 2 arrows. Whatever. Like, if I draw it out, that gives you context. The verbosity of just verbalizing what a square is, that is actually the next thing. That's extraneous cognitive load. It's cognitive load that is extraneous to the intrinsic problem. It's not a part of the absolute complexity we are trying to solve, the non-changing complexity. We are adding layers of complexity, and that's not good. That's not good at all. So let's break it down this way. Extraneous cognitive load has actually 2 definitions. This is one of the reasons this is my favorite. First definition. In terms of human cognitive load. Human extraneous cognitive load. Visual debt. Having a bird chirp in the background during a classroom talk. Trying to communicate one-on-one with somebody and having a blowhorn in your ear. These are all examples of extraneous state or extraneous cognitive load. It's load on your cognitive ability, on your cognitive limitations that are extraneous to the cognitive or complexity of the intrinsic problem. Extraneous state for a human. Now, what's cool about extraneous cognitive load is you can take this into the software world. So let's take, for example, functional programming. Gotcha. Brought that up twice now. Now, functional programming has these things called pure functions. Pure functions. Output is the same per input. This is extremely powerful, and as we talked about in our last video, it makes TDD test 100% reliable. versus TDD tests that are implemented in an object-oriented paradigm, they're not 100% reliable because we usually don't test every possible state or application can be in. Edge cases can fall through. Tests aren't 100% reliable. Functional programming, on the other hand, is made of pure functions, meaning they have the same output per input and they depend on zero extraneous state. That's why a pure function is pure. It does not depend on extraneous state. It doesn't depend on state outside of its input and what is within the scope internally of that function. And it never mutates anything outside of itself. It never has the ability to mutate extraneous state. So the output is the same per input. No matter what you input, you will get the same output. No matter what you input, the output will be the same. For example, like you make a function and then it's, accepts a number and then it's return, it accepts x and you return x plus 2. That's a pure function. It accepts x and it returns x plus 2. So it returns whatever the input is plus 2. The input can change the output, but the output is always the same functionally. It's always the same based on the input. The output is the same per input. It never depends on, for example, a global variable. If you use a global variable inside a function, it's not a pure function. So that's a pure function. Now here's another really, really cool thing in closing, guys, is if you think about cognitive load and these three areas of cognitive load, the first being intrinsic cognitive load, the absolute difficulty of a problem. Germane cognitive load, the schema surrounding the problem, the context, the semantics, the variable names you use, is versus has versus contains, like those, what do those return? What are those checking? And yes, they are all checks. Is, has, contains. Those are true or false. Those are going to return booleans. That's context. That's semantics. And then the third one is extraneous cognitive load. And that is just saying don't depend on extraneous state. Or if you are, which you do in an object-oriented paradigm, and I definitely recommend object-oriented paradigms over functional, just take into account how often you're depending on extraneous state, how well you're encapsulating that state, how well you're just implementing and containing scope, and just take into account that if you depend on extraneous state, you're changing a lot, and it's just another dependency. Whereas a pure function only depends on its input. Non-pure functions depend on its input and the state of extraneous global things, or non-global, just things that it can get within the function scope that aren't input. And the problem with that is now you depend on that global thing. Well, what's that global thing depend on? Well, that global thing may depend on something else that's global, or something else that's not global. It might depend on another function. And all of a sudden you get this train wreck of dependencies going everywhere. So try to encapsulate and take into account extraneous cognitive load. Try to take into account limiting your visual debt, keeping the text or the content on the left side of the page when you code. Use words, not freaking acronyms, people. God, no acronyms. Get rid of them. Acronyms don't exist. Or at least I wish they didn't. And then just take into account the intrinsic problem. And one of my coolest thoughts on intrinsic problems, on the intrinsic cognitive load of a problem, is this. TDD test. And people are going to start thinking I don't like TDD tests. This is my second video I've had on them where I'm saying bad things. But that's not true. I do like TDD tests. But just take into account the fact that TDD tests, test-driven development, or any testing, adds complexity to the problem we are trying to solve as software developers that is not intrinsically necessary to the solution of that given problem, which is just creating one application, whatever application we're creating. So, that's another thought on TDD tests. Again, I am for TDD tests. Not if you want to learn architectural design patterns like solid, single responsibility, open, close, list scope substitution, dependency inversion, and interface segregation. I flipped the D and the I there. It's interface segregation, then dependency inversion. Or GOF principles, gang of four principles, which is GOF. Or GRASP principles, which is general responsibility assignment software principles. Or DRY. Do not repeat yourself unless you're trying to provide Germane cognitive load. See what I did there? Don't use acronyms, people. Write good code. And understand your damn job, which is managing complexity, which is understanding what is necessary to the intrinsic problem and to the intrinsic cognitive load, which is providing a very contextually, semantical, understandable Germane cognitive load. And then third is trying to reduce the dependence on extraneous cognitive load. So guys, this is Zachary Horan with Clean Code Studio, Clean Code, Clean Life. If you guys learned something, thought this was interesting, valuable, insightful, maybe you learned some new words, maybe you have a new perspective on the way that you're thinking about software, even if it's just a small new perspective. Like and subscribe below. And guys, I will keep making these videos. I'll see you guys next time. Appreciate it.